Hi team. Today you're going to be able to calculate experimental probability. So please find your notebook and take a second to write down this objective and today's date at the top of your paper. You can pause your YouTube to do that now. Okay, I wanted to start off today's lesson by going over the new rubric. So this is how you're going to be graded on this assignment today. So, of course, you're going to do a Khan Academy assignment, practice assignment. It's called Experimental Probability today. And you'll be earning 40 points on the rubric if you score between a 100% and an 80% on the assignment. You'll get 30 points if you score between a 79 and a 60, 20 points for 59 between 40, and 10 points if you score a 39% between a 20%. And you'll earn 0 points if you do not complete the assignment on Khan Academy. Moving on to the video notes section, so you will earn 30 points if you have the date and objective, if you have the vocabulary notes, if you have the criteria for success, and if you have 4 examples worked step by step. You'll earn 20 points if you have 3 of those 4 components, 10 if you have 2 of those 4 components, and you'll earn 0 points if you have less than 2 of those components for your video notes. Okay, so for your practice strategies, 30 points if you have 4 problems solved using the criteria for success step by step. 20 points if you have 3 problems solved step by step using the CFS, and 10 points for 2 problems solved step by step using the CFS. And 0 points if you do not submit a picture, if I can't read your picture, or if you do not solve 2 or more problems using the criteria for success. So right now you might be wondering about this Khan Academy score. So if you're a Cardinal, I am going to, in this video, model some problems from your assignment. So that means anybody could see these problems randomly on their assignment, but all of the Cardinals will be seeing these problems. So that will help the Cardinals score hopefully up in this range. Okay, take a second to jot down this key vocabulary, experimental probability. So today you're going to be able to calculate experimental probability. Experimental probability is the likelihood of a favorable event occurring based on past observations. And so we write this by finding favorable outcomes over the total number of outcomes. And it can be expressed as a ratio, a decimal, a fraction, or a percent. And like I said, pause to write down this key vocabulary. You do know that it contributes to part of your video notes. Okay, criteria for success today. So as you're solving on Khan Academy, the first thing you will do is identify the favorable number of outcomes. Then you'll identify the value of total number of outcomes. You'll construct step 3, a ratio, decimal, fraction, or percent. And the 4th criteria of success is you might have to simplify or convert. Okay. So Cardinals, here is your number 1 Khan Academy assignment question on experimental probabilities. It reads, the following frequency table summarizes yesterday's orders at Sizzlin' Skillets. So we have types of stir fry, we have number of orders. Based on this data, what is a reasonable estimate of the probability that the next type of stir fry ordered is shrimp? Okay, so if you remember back from the previous slide, the first criteria for success was to identify favorable outcomes. So this problem is asking me for shrimp. So looking back at this table, I can see that the favorable outcomes of shrimp is equal to 5. Okay, now moving on to criteria for success number 2, I know that it is the total. I need to find the total number of outcomes. And to calculate the total number of outcomes in this problem, I would need to add vegetable, chicken, pork, beef, and shrimp. So I'm going to add 3 plus 6 plus 2 plus 2 plus 5 to get 18 total outcomes. All right, moving on to criteria for success number 3. Criteria for success number 3 says to set up my ratio, my decimal, my fraction, or my percent. So I can see that the end goal is decimal because all of my answer choices are in decimal form. So setting up my ratio, my probability, I remember experimental is equal to favorable over total outcomes. So I have 5 favorable out of 18 total outcomes. 5 out of 18 are shrimp. So because I need to get this to a decimal form, I'm going to take this top number and divide by this bottom number. So I'm going to take 5 divided by 18 using my calculator. So feel free to grab your calculator. 5 divided by 18. When I do that, I get 0.2777, and I'm going to round to the nearest hundredth, so I get 0.28 as my answer. So the probability of shrimp stir fry occurring next is 28 hundredths. 28 hundredths. So this right here was our criteria for success number 4. We had to convert this fraction to a decimal. We had to convert this fraction to a decimal. Okay. Everyone has these notes written on their paper because now we're moving on to number 2. Cardinals, this is number 2 on your Khan Academy assignment, experimental probability. It says Tiny's Tattoo Parlor sold 389 tattoos this month. 43 of those tattoos were arm tattoos. 43 were arm tattoos. Based on this data, what is a reasonable estimate of the probability that the next customer does not get an arm tattoo? So we are going to determine the probability that the next customer gets something somewhere else on their body, not on their arm. Because criteria for success number 1, our favorable outcome is every tattoo not on your arm. Tattoo not on arm. So looking back at this problem, we know that there's a total of 389 tattoos. So then we need to subtract the number of tattoos that are on the arm, which are 43. And so the number of tattoos not on the arm is equal to 346 tattoos. This is our favorable outcome, not on the arm. Moving to criteria for success number 2. So you'll notice how this required an extra step of subtraction. Okay, criteria for success number 2, the total number of outcomes. Well, we know that that's 389 tattoos because we labeled that earlier. Great, now we're ready. Now we're ready to move on to criteria for success number 3, which is to write the experimental probability. And the experimental probability in this situation will be 346 tattoos not on the arm out of 389 tattoos total. And then in number 4, looking at my answer choices, I don't have to simplify or convert. So my answer here is 346 out of 389. Did not have to simplify or convert. Okay. Moving on, Cardinals, to problem number 3. Hopefully all of us have this written down because now we're moving on. Okay, problem number 3 reads, the Pines Golf Course is offering free ice cream cones to golfers who hit their tee shot on the green at hole 7. The following bar graph summarizes the tees shot from this morning. Okay, so we're going to use this bar graph to figure out our criteria for success. So criteria for success number 1 is the favorable outcome, identifying the favorable outcome. Well, the favorable outcome is green. So looking at this bar graph, I know that green had 4 occurrences. Moving on to criteria for success number 2, if I'm trying to figure out the total number of outcomes, I'm going to use the bar graph to determine those values. So I'm going to be adding 4 for landing on the green. I'll add 5 for landing on the water. I'll add 7 landing in the bunker. I will add 3 for landing on the fairway. And I will add 5 for landing in the rough. So when I add all of these together, I find out that there is a total of 24 outcomes. Moving on to criteria for success number 3, I'm going to set up my experimental probability, which is equal to 4 out of 24 outcomes total. And now looking at my answer choices, my answer needs to be in percents. So I need to convert this fraction to a percent. So the way that I'm going to do that is I'm going to take 4 divided by 24 and then multiply it by 100. So using my calculator, I'm going to take 4 divided by 24, multiply it by 100, I get 16.67, or approximately 17% of a chance that the next time someone golfs, it will land on the green. It will land on the green. Okay, everybody has these written down because we know that they're contributing to our notes. But we're moving on to problem number 4. Problem number 4 reads, Pat's Pizza made 21 cheese pizzas, 14 veggie pizzas, 23 pepperoni pizzas, and 14 sausage pizzas yesterday. Based on this data, what is a reasonable estimate of the probability that the next pizza made is not a cheese pizza? So, referring to our criteria for success number 1, which is to identify the favorable outcome. The favorable outcome in this problem is not cheese pizza. I need to make sure I pay attention to that in the word problem. Not cheese pizza. So to do that, I'm going to add all of the totals that are not cheese. 14 for veggie, plus 23 for pepperoni, plus 14 for sausage, and I find out that there are 51 pizzas that are not cheese total. Now moving on to criteria for success number 2, the total number of outcomes would be 51 pizzas plus the total number of cheese pizzas, which is 21 cheese pizzas, to find out that there are 72 pizzas total. Now moving on to criteria for success number 3, which is to set up our probability, I will have my likely or my favorable outcomes, which are 51, out of my total number of outcomes, which is 72 pizzas total. Moving on to problem number 4. Look at my answer choices. It looks like I need to get to a percent. So I need to convert this fraction to a percent. And I'm going to do that by taking 51 divided by 72, so top divided by bottom, and then multiplying it by 100. So using my calculator, I'm going to take 51 divided by 72. I get 0.708. Then I'm multiplying that by 100. And then I'm going to round this percent to the nearest tenth, to the nearest 1. So this rounds to be 71%. 71%. So the probability that the next pizza made is not cheese is about 71%. Next pizza, not cheese. 71%. Okay, so I've modeled 4 problems for you now. Cardinals, those are 4 problems directly from your assignment. Everyone else, so if you are a lab, if you are a dolphin or a frog, you have copied all of those examples down because those are